Hello everyone, this is Mathematics and we are here with the third chapter of Pure Mathematics 1, which is Equations and Inequalities. Guys, this chapter consists of equations and inequalities contents, and I have planned to merge the equations contents in one video and the contents for inequalities in another video, so we can finish this chapter in at most 3 videos. The thing that I have planned is 2 videos. And let's get into it. Let's get into equations and then in the next session, inequality. Alrighty guys, so as for section 3.1, well, I have meshed sections 3.1, 3.2 and 3.3 in this video. So we will start with linear simultaneous equations. Okay, let me underline it as well. Beautiful. So whatever that you need to know, guys, well, how do we solve it? By 2 ways, guys: elimination or substitution. Well, guys, linear simultaneous equations, we even had this in IGCSE, and it is not very hard or that hard compared to the other sections of this chapter. So at least I expect you to know this, or at least if you don't know, then try to master it as soon as possible, because we need it for the next parts of this video. So let me write an example. This is from exercise 3A, question 1, part D, where it wants us to solve the simultaneous equation 2x minus y equal to 12, 6x plus 2y equal to 21. Well, guys, I'm gonna solve this in 2 methods, one for elimination and one for substitution, so you can use whichever you want. For these kind of questions, guys, I told you can use whichever, but I would personally prefer elimination, because you see here, if I multiply it by 2, then it will be minus 2, right? So we'll get into the solution, but if you want to do the substitution, you have to make y the subject, and you have to replace it, substitute it in another equation, and do a lot of stuff. So let me write it: elimination. Okay, alright, so 2x minus y equal to 12. I will multiply the whole equation by 2. It will become 4x minus 2y equal to 24. So guys, I'm gonna write the second equation side by side to it. So it will be 6x plus 2y equal to 21. So something interesting is happening, guys. I can add these 2 equations. I can add them up together. So if I add them up, 2y and minus 2y will cancel out. 4x plus 6x will be 10x. And 24 plus 21 will be 45. So x will be equal to 4.5 or 9 over 2. 4.5. Now, what did I have? I had 2x minus y equal to 12, right? If I replace x, if I put x equal to 4.5, then it will be 9 minus y equal to 12. So y is going to be equal to minus 3. So this is how we do it with elimination. Guys, if you want to see if your answer is correct or not, just put these 2 values that you figured out, this value and this value, put them into the second equation, which is this one, or the equation that you haven't used for figuring out your answer. So if I put x as 4.5 here, let me just use the calculator. 6 times 4.5 plus 2 times minus 3. 2 times minus 3 will be 21. So my answers are correct. So as for substitution, okay, the question was 2x minus y equal to 12 and 6x plus 2y equal to 21. Okay, here I can make y the subject of the equation very easily, right? How? By putting y here and bringing 12 here. Y will be equal to 2x minus 12. And now I can put this into the second equation. So I will have 6x plus 2 times 2x minus 12 equal to 21. So 6x plus 4x minus 24 will be equal to 21. So 10x will be equal to 45, and as like the previous solution, x is equal to 4.5, right? And for y, I made this equation myself, right? Well, not really. I used it in I just rearranged it. So the equation is from the question, but like you can find y much more easily, right? So y is going to be equal to 2 times 4.5 minus 12, which is going to be minus 3. And this is your answer. Again, if you want to check your answer, just put it back and substitute it into the second equation, or the equation that you haven't used for figuring out the values for x and y, right? That you haven't used for the values of x and y, or only the y, however that you may figure out yourself, which will be easier for you. Okay, yes, we are finished with linear simultaneous equations, and let's go to quadratic simultaneous equations. Let me label it as no. Okay, quadratic simultaneous equations. Guys, for quadratic simultaneous equations, this happens where the maximum power of either x or y, or even x and y, is 2. Their maximum power is 2, and it will form a quadratic, right? So, as for quadratic, guys, we know that like when we were solving quadratics in the previous chapter, if you remember, the quadratics like for x, for the unknown, for the variable, will have 2 answers, right? Like in most of the cases, they will have 2 answers when the discriminant is greater than 0. In quadratic simultaneous equations, you will have 2 answers for x and their corresponding answers for y. So you have to pair them up, the answers for x and y, correctly, and give, in general, 4 answers to the quadratic simultaneous equations, 2 for x and 2 for y, right? In linear ones, we were giving 1 answer for each, 1 for x and 1 for y. But here we have to give 2 answers for each, 2 for x and 2 for y. Okay, then let's go. Alright, question 4 of exercise 3b. We have x plus y equal to 3 and x squared minus 3y equal to 1. Guys, for quadratic simultaneous equations, you have to use substitution. Substitution is your only way of doing this quadratic simultaneous equation, alright? I have a power of 2 for x, and it's just a y here, and I don't have y squared or something. So it will be easier for me to substitute in the place of y, right? So I will write this equation in terms of y. Y will be equal to 3 minus x, right? So now I can replace x squared minus 3 times 3 minus x equal to 1. Minus 9 plus 3x equal to 1. X squared minus 3x minus 10 is equal to 0. So x minus 5 times x plus 2 is going to be equal to 0. So x is equal to 5. X is equal to minus 2. These are your 2 answers for x and for x. Why did I say and? For x, guys. Y is equal to 3 minus 5 equal to minus 2, and y is equal to 3 minus 2 equal to 5. So now you have to write your answers for x and y in pairs. How? You're either gonna write 5 and minus 2 and minus 2 and 5. This is one way of writing it. Another way, you can write it as x equal to 5 and y equal to minus 2, or x is equal to minus 2 and y is equal to 5. This is another way of writing it. And let's just solve one more example from quadratic simultaneous equations. Question 3 of exercise B. The question has asked us to give our answers in its simplest third form. So we know that we're not gonna have real answer. We're not gonna have rational answers. So this is a good hint. 2x plus 3y equal to 13. X squared plus y squared equal to 78. So see, x squared, y squared, really doesn't matter which one you make the subject in here. Well, just as for the hint, guys, if you haven't figured it out yourself, the thing is, in quadratic simultaneous equations, you make y or x the subject in the linear equation, because your quadratic simultaneous equation consists of one linear and one quadratic, right? So in the linear one, you make the substitution. You want to see which one is going to be the substitution in the quadratic one. So if you want to make x the subject, just make it subject in the linear one. If you want to make y the subject, then just make it subject in the why did I say y? In the linear one again. Whatever rearrangement of equation that we are going to use is for the linear equation, and we're gonna substitute the thing that we have figured out in the linear equation into the quadratic equation. So 2x plus 3y equal to 13. So you can write it as y equal to 13 minus 2x divided by 3. Right. So now, as I said, you substitute this one into the quadratic equation. X squared plus 13 minus 2x over 3 squared equal to 78. Right? So it will be x squared plus 13 minus 2x squared over 9 equal to 78, which is going to be x squared plus 4x squared minus 2 times 13 times 2, which is going to be minus 52, right, plus 169 over 9 equal to 78. I will multiply the whole equation by 9 because I hate the fractions. Okay, 9x squared plus 4x squared minus 52 plus 169 equal to, okay, 78 times 9, which is going to be 702. So in the end you will have 13x squared minus 52x minus, okay, 169 minus 702, 533 equal to 0. So since it has third form, I'm just gonna use the formula directly. My A is going to be 13, my B is going to be minus 52, and my C is going to be minus 533. So my X is going to be equal to minus 52 plus or minus root minus 52 squared minus 4 times 13 times minus 533. Good. And here over 2 times 30. So I'm gonna have 52 plus root 52 squared plus 4 times 13 times 533 over 2 times 13, which is going to be 2 plus. So x is going to be equal to 2 plus 3 root 5, and most probably x is going to be equal to 2 minus 3 root 5. Just to make sure. Yes, right. So, and for y, we know that y is going to be equal to, okay, 13 minus 2x over 3. 13 minus 2x over 3. So, let me just write it here. Y is going to be equal to 13 minus 2 times 2 plus 3 root 5 over 3, and y is going to be equal to 13 minus 2 times 2 minus 3 root 5 over 3, which are going to be, okay, 13 minus 2 times 2 plus 3 root 5 over 3. 3 minus 2 root 5, and if I make this one minus 3 plus 2 root 5. So my answers are gonna be, wait, what is the ruler saying here? X equal to 2 plus 3 root 5. Okay, just let me write it in the middle. X equal to 2 plus 3 root 5, and y is equal to 3 minus 2 root 5, and here x is going to be equal to 2 minus 3 root 5, and y is equal to 3 plus 2 root 5. And this is our final answer, guys. And just remains one more point in this section, which is discriminant for simultaneous equations, guys. Well, this is mentioned in section 3.3, which is simultaneous equations and graphs, but really, you're not gonna be asked about solving the simultaneous equations and graphs in the exam. But the very important point is the use of discriminant. How? Okay, guys, I said that in quadratic simultaneous equations. Okay, let me draw it. Y, x. In quadratic simultaneous equations, you will have one linear equation and one quadratic equation, right? Let us say that this is our, okay, let me draw it with purple. Let us say that this is our quadratic, not really symmetrical. Okay, this one's better. And one linear. Let us say this one is the linear. So, whatever question that we were solving here was like this. How? It had two intersection points. Guys, if you have two intersection points, it means that your equation is going to have two pairs of answers. My English, sorry. Answer. Right? Two pairs of answers. One here, which we can call x1, y1, and one here, which we can call x2, y2. Till here, we were figuring out the values for x1, y1, x2, y2, right? But in some cases, if you have this axis, okay, y, x, if I have this one as my quadratic and have this one, no, not really, and have this one as my linear, so guys, this line is tangent to the curve and they touch only at one point. They intersect only at one point. And it is gonna be x1, y1. And what is different between this one, and this one? What is different? Well, I'm gonna say that discriminant is different. Okay? Here, b squared minus 4ac is greater than 0. Right? And here, b squared minus 4ac is equal to 0. And as for the third case, y x. If I have this quadratic and this line, you see that they do not intersect. If they do not intersect, then I will have no answers for the simultaneous equations. So b squared minus 4ac less than 0. So these are the cases, and they are very important, guys. We're gonna use this very much in equation of the straight line, which is chapter 5. And in the exam, they will definitely ask you about this. So it will be important for you to remember, okay? And we're gonna do question 8 of exercise 3C. So, and then we will end the video. So this is just an exercise. Let us do it. It will be exercise 3C, question 8. Okay, the question is in 3 parts. Given the simultaneous equations, okay, let me write the simultaneous equations. 2x minus y equal to 1 and x squared plus 4ky plus 5k is going to be equal to 0. So, where k is a non-zero constant, alright, show that x squared plus 8kx plus k is equal to 0. Show that x squared plus 8kx plus k is going to be equal to 0. Alright guys, so 2x minus y is equal to 1. So if I make y the subject, it will be 2x minus 1, right? So I'm just going to replace this into the second equation. X squared plus 4k times 2x minus 1 plus 5k equal to 0. So x squared plus 8kx minus 4k plus 5k equal to 0. So x squared plus 8kx plus k is going to be equal to 0. Therefore, shown. Alright. And as for part B, given that x squared plus 8kx plus k equal to 0 has equal roots, find the value of k. So guys, we have one repeated root, alright? When we have one repeated root, it means that the discriminant can be denoted as this one as well, guys. b squared minus 4ac is equal to 0. So what is the discriminant of this equation? A is equal to 1, b is equal to 8k, and c is equal to k. So my discriminant will be b squared minus 4 times a times c equal to 0. Right? In this case, since we have one repeated root, or we have equal roots, then the discriminant is going to be equal to 0. Sometimes they tell you that we have two distinct roots. We have two distinct real roots. And they want you to find the range for k. And sometimes they tell you that you have no roots, no real roots. And then they want you to again find the range for k. And those cases are going to be applied different. What do I mean by different? It is gonna be either this one or this one. But in this question now we have the equal sign. So 64k squared minus 4k is going to be equal to 0. So I can factorize the 4k from here. It will be 16k minus 1 equal to 0. So k is going to be equal to 0. K is going to be equal to 1 over 16. However, in the question it is mentioned that k is not equal to 0, where it has said that where k is a non-zero constant. So our k is going to be equal to 1 over 16. And now it says, for this value of k, find the solution of the simultaneous equations. Alright. So what was the equation again? Part C. Okay. It was x squared plus 8kx x squared. Okay, what is 8k? 8 times 1 over 16. 8 over 16, which is 1 over 2. I will simplify it. X plus k. 1 over 16 equal to 0. So since I hate the division, I just multiply this one by 16. It will be x squared plus 8x. 16x squared plus 8x plus 1 equal to 0. And then I will have 4x plus 1 squared equal to 0. So x is going to be equal to minus 1 over 4. Right? And for y, I have what? What was for y? Y is equal to 2x minus 1. So y is going to be equal to 2 times minus 1 over 4 minus 1, which is going to be 2 times minus 1 over 4 is going to be minus 1 over 2. Minus 1 over 2 minus 1 is going to be minus 3 over 2. So x is equal to minus 1 over 4 and y is equal to minus 3 over 2. And guys, this is whatever that you needed to know for the equations in Pure Mathematics 1. And this is it for the first part of chapter 3. And thanks for watching this video. If you like this video, please like the video. And then yes, just write comments. Guys, I'm not good at this, seriously. Then just please do whatever that you can for supporting us, and we really appreciate that. Do not forget to subscribe our channel as well. And till the next session, see you all.